So, number 4. You can't tell what the numbers are, but you know the time is in minutes, and you know that we're talking about distance as we look at number 4, and the distance is in miles. So the first thing you have to do is, you can't find a point here, but this first point right here, we want to put that point. And then we want to go to the next point where they're called nice lattice points, or where the two vertical and horizontal lines intersect. So if on number 4, you did not put those 2 points, please make sure you put those. And then to find the unit rate is always going to be change in y divided by change in x. So everyone, let's say that together. Unit rate equals change in y divided by change in x. Okay, we need to do it again because some of you aren't with it. So, unit rate equals change in y divided by change in x. So, the y change, that's our vertical. How far did you have to go up from this point to this point? And in your workbook, it'll probably be easier to count. So in number 4, count how high are we moving up. We are moving up 1, 2, 3 units. So we're going to say 3, and our unit was miles. And how far did you move across? So that is going to be from this point going over. How far are we moving over? 4. So I am going 3 miles in 4 minutes. So when I look at that answer, I might say I'm going 3, yesterday in the video they said you can leave it, 3/4 of a mile per minute, right? Okay, so 3/4 of a mile per minute. Could I say 0.75 of a mile? Yeah. Same thing, right? So as I am looking at that, okay? As I am looking at question 6 and question 7, they are telling us that our unit rate, C, is equal to 5W. What that tells us is that our unit rate, and today we're going to have more practice writing equations, unit rate is 5, in this case, dollars per pound. And so if you write it out that way, or if you write it out $5 per pound. Now on this one, I would definitely probably have my scale maybe going by 5s, because that's what my unit rate is. So I'd have 5, 10, 15, 20. And if I have 1, and in this case I need to label these. These are my dollars that I'm talking about. This was my weight. So when I'm looking at your graphs from D2, there was quite a few people that didn't put any labels on theirs. I need labels with you is what we're talking about. So at 0, 0, it was 5. 0 was 0. When I put in 1 pound, it cost me $5. So that ordered pair, 1, 5, 1 at 5, 2 at 10, 3 at 15, and I'm going to draw that straight line. But it depends on the scale you use. Okay, so I'd be looking for that. In number 7, it says write an equation. So when we write an equation, at 1, can we tell what this point is going across? Our unit rate changing is what?
20.
Equals 20 per 1 in this case. We don't know what the units are. So it says write an equation. So for an equation, right below number 7, or right by number 7, equations are always going to be in this form. We're going to work a ton more with this today. Y equals, it's always going to be our unit rate times X. So your answer for number 7 should be Y equals, our unit rate was 20 over 1. And you can put 20 over 1, or you can just write 20. So today we'll practice more of these same ones. So I appreciate those of you that if you didn't have it done, you're kind of checking yours and making sure you have the right answer. Since I'm going through the time to do it, those of you that aren't, this would be the time in your workbook that you'd be filling these in if you didn't have them done. So we're looking at 9, 10, 13. I'm not going to do all of those, 9, 10, 11, 9, 10, 12, 13. But as you take a look at number 9, it is very much like the last one we did. D equals 17. So if we are looking at the equation, what is our unit rate? Unit rate, if I'm looking at this one, Aaron, should be?
Unit rate equals 7.
Okay, 7 over 1, and we were talking about 7 what? 7 miles per 1 hour. So when I go to graph number 9, I'm going to put my time in hours. I'm going to have my distance up here, and it's going to be in miles. I might not go by 7. Maybe I go with 2 blocks up is going to be 7, and then I'm going to have 14, and then I'm going to have 21. You can set your scale, but the key thing is that if I'm setting my time, I might even skip a line here and put 1. If you didn't, that's okay. But at 0, it's 0, at 1, it's 7, at 2, it's 14, at 3, it's 21, and I'm going to continue like that. That's how you are graphing those every time you're asked to do those graphs, okay? And then once you have your graph, you should extend that line, just like all of these have a line, okay? Number 10 says, which store offers a better buy? Just like our notes yesterday, you have to tell me right below unit store A, what was our unit rate? Nathaniel, if I'm looking at this equation, what's my unit rate in that equation? It'd be, so wait, the unit rate is just going to be 3, and in this case, it's going to be dollars per pound, right? 3 for store A, right? Because it was a 3 in my equation. Maddie, when I look at the graph, so this is kind of like how you're doing 11, 12, 13, so I'm not going to do all of these. So in this one, Maddie, what can I tell at 1? Can I tell the unit rate? For store B, it was what? $4. So unit rate for store B was $4 per pound. Which one is a better buy, store A or store B? A is cheaper, right, for the same product. So which store is a better buy? You might circle store A, or you might write down here, store A is a better buy. And the reason store A is a better buy is because it's cheaper than $3 is less than 4, right? So it's cheaper, okay? $1 less per pound. So like it's like saying you're going in to buy the same type of salad at 2 stores. You go to Hornbacher's at Family Fair, and at Family Fair, same potato salad is $3 a pound, and at Hornbacher's it's $4 a pound. Well, better buy would be to go to Family Fair, right? So you want to get those. That's what they're talking about. When you're talking about which one is faster, so 13 and 10, very similar questions, right? Here, though, they tell you the store in $11 per 4 pounds. So what do you have to do different in 13? You have to find the unit rate. How do you find the unit rate for that store? You have to take the $11, that's your Y, and you're dividing it by 4 pounds. You need to find out per 1 pound, okay? So you simply take 11 and divide it by 4. That should help you. Then you're going to go to your graph. You can't go to 1, right? So you have to use this point, okay? I'm not going to finish that one, but you have time in class to work it out. This is almost exactly the same. Here you have to find your unit rate. So for each of these, you have to find unit rates. When I look at each one of these problems, you have to find your unit rate. How do you do that? Well, in this one, you look at the equation. In this one, you have to do it the same as we just talked about in 13. You have to divide the miles by the minutes. You want to get a decimal in question 11 because you are comparing that to this amount, which is over here at, where was our point on the line? Was it here at 5? Yep. Yeah, 5, 6. That's the point you want to use on the graph. Are there any other questions as you look at that?
Or others yearly salary. How often people are paid also varies.
So it says, how could we compare the income of 2 workers based on their paychecks? If you just look for paychecks, what would you want to be looking at? What do you think in order to check to see who earns more than another person or to compare them? What would we want to look at? How much they get paid what? In a week or in a month, right? We can compare it that way. So how can we find out how much a worker earns over time? What do we have to do? So if I get a monthly salary, could I find out how much I make per week? Yes, I divide it by how many weeks we're in that. If I wanted to find out how much per hour, right? Because there's sometimes hourly employees, so depending on when you are working or where you are working. So we are going to be looking at this employee, right? On that next page down in your notes. And it says Lacey works as a temporary employee. Last week she worked a total of 20 hours and earned $300. Find her unit rate. So when we come back from lunch, we will do that. Okay, anytime we talk unit rate is per one, and in this case we'd be talking about per 1 hour, right? So the key thing yesterday on that unit rate, on that quiz, when I just asked you to find the unit rate, it was per 1 that we were looking at. So that's the key thing anytime you find unit rate. So in this case, we were told that her earnings are $300, so let's put $300. And she worked for 20 hours. So on your calculator, please take and divide, or you want to just take 2 goes into 30, right? Because you can take the zeros off and 2 goes into 30, and she is making $15. And if you want to write it out this way, per hour, or you can write it this way, $15 per hour, right? So this line, right, that line for division means per that we are talking about. It says this week, she had a total of 35 hours. How much money will she make? So we are going to take our pay per hour, $15 per hour, and we're going to take it times 35 hours. So please, you do probably need your calculator for this one. So 35 times 15, so put it in your calculator. Don't have a calculator, grab a calculator, I have some up in front. Should be 500 and, so we're going to put $525, and that was for her work week, right? So that was per week that we were talking about. It says, well, next week she had a total of 40 hours, so now she's working more hours. So this time we are going to take our 15, so write it out this way, $15 per hour, and we're taking it times, this time, our 40 hours. So if we are looking at that week, she is making, yes, you can use one of those calculators. She is making $600. Now they haven't taken out taxes or anything else. That was simply just how much she made in that. Okay, so $600 in. If we wanted to think that was in 40 hours, right? You could also have written it as $600 per, in this case, that was in the 1 week that she worked, right? So here, $525 per week, or $525 for 35 hours. On this next page, we're going to be looking at making our graphs. So in your homework tonight, you're going to be asked to find the unit rate as you start off. But now we want to look at our graphs. So this says using the unit rate from the table, we're going to graph our 0 to 5. So our independent variable, or our x, is going to be time, or our hours worked. So please put x is going to be our time or hours worked right up on top. Fill that in. Our y is going to be our dependent variable, and that would be, in this case, our what? What are we talking about? Our, we should be talking about our money that we got paid, our dollars, money paid, our salary, however you'd like to write that, the amount of money, that's our dollars, right? That's our salary. That's how much money we got paid. So when we look at this table, above the table I want you to write x and y. X is our hours. That's our time. Y is our dollars, or our pay. We are getting paid in dollars. Okay. 0 hours worked. 0 paid. 1 hour work, we said she was making how much per hour? 15. 2 hours, 30. Now start plotting your graph. So 0 was at 0. 1 was at 15. Someone said, how do I graph 15? Well, it's halfway between 10 and 20, so put a point. 2 is at 30. So please continue filling in your table if you haven't already done that. Okay? And if we look at our graph, once you plot your points, we then want to extend that with a line. So we had at 3, we had 45, right? So halfway. And we're going to have 60 and we're going to have 75. And then please take the edge of your workbook, straight edge, and we want to draw that line. And we want to make sure we have, in this case, because if she keep working more hours, we could figure out what that pay would be. We continue going. Okay? So what we're also going to do is today we're going to do a lot more work with writing those equations. So if yesterday the writing equations didn't make sense, so you're going to be asked to make a graph of the situation. If you now look at that next part down, making an equation. So we're going to look at that making an equation. As you are making an equation, if you would start reading, Ella, what does it say we're going to do first? Yep, we want to think about it in words. So we want to think about we're looking at the amount she was paid. Would you say that was my independent or dependent variable looking up in your graph? This is our dollars here, right? That's how much she got paid. And so we put our labels back on this graph. And this was our hours. So the amount she gets paid, that is our dependent variable, right? X is independent, Y is always dependent. So when we are looking at that, the amount she was paid, that's really our Y, right? Is equal to, we are going to say her pay rate. And when we talk about that pay rate, we're actually talking about it as we really would like to put it as not $300, right? And 20 hours, we want to write it how? As a what? Unit rate. So this is always going to be our unit rate. So her pay rate. And then it's going to be times, and then we're looking at the hours that we worked. And the hours that we worked, we said, was our independent variable, which is X. So it says generalize this proportional relationship. This is how we want to write that. So when you are looking at that, we are going to put the dependent variable equals our unit rate times the independent variable. When you write most of your equations for these first few units and yesterday's homework also, Y equals, we're going to call it unit rate M. The reason we're going to call it M is that later in our unit we call it our rate of change. We call it the slope times X. And this number will always, always be our unit rate. Okay? So dependent variable, some of you haven't written that yet. Dependent variable equals the unit rate times the independent variable. Right below it, put Y equals MX. Okay? And with that M, make sure you put that is the same as your unit rate. Okay? So M is going to be a number, it's going to always be our unit rate. So it says, in summary, if we were going to model her pay on the table graph and equation, how would each unit be represented? How would the unit rate? So how do we show this unit rate in a table? So as you are looking at this, I think their writing is a little better than mine, so I'm just going to move this down so that you can see it. So please copy what is here as you are looking at this. So if we are looking at the table, when you look at the table, the numbers in the Y column are always going up by 15, right? So anytime you're looking for the unit rate in a table, if you look back up on problem 3 of your notes, you notice that the Y's the pay always went up by 15. It was 15. It was 30. It was 45. So the numbers in the Y column go up by 15. How did we show it on our graph? Look up at your graph up above. How did we show unit rate on our graph? As you went over 1 unit, how far did you go up each time? 15 every single time. So in a graph, the line pattern would always go up by 15 and over 1. And we're going to say over 1 to the right. So as you move over 1 unit to the right, we went up 15, correct? So we went up 15 each time we moved over 1 unit on our graph. And again, if you look back at your graph, that's exactly what we did. We went up 15 and over 1 unit. Up 15 over 1 unit, right? Our table here, this is where we went up and we added 15 each time as we were looking at that table. So those are the two we've looked at so far. Now we want to look at the equation. Where do we put the unit rate in our equation? That last one, we are putting the unit rate times which variable? Independent or dependent? Independent. So we want to put, for that last one, the equation would have 15 in it, and more specifically, so the equation would have 15 in it, and our equation is going to be y equals 15 times x. So it is always y equals the unit rate times x for an equation. Y equals the unit rate times x. Top of the next page, Stephen, please start reading for our next employee that we want
Joseph is another temporary. He was paid $513 for 38 hours of work. Find Joseph's new rate.
So we're going to start with doing what? What do I have to do with his pay and how much he worked? We're going to divide. So please, same thing in your homework tonight. 513 divided by 38 hours. If you don't have a calculator, there's calculators in front. Grab one. Do that. Let's do that division. Once we did that, how much would you say, Nikita, he's getting paid per hour? So 513 divided by 38. Not 30, 38. Go 38. Should have been more. Or it should have been less than. $13.50. Okay? So $13.50 we're going to put per hour. So it says create Joseph's pay, just like we did for Lucy. So 0 was 0, right? 1 is going to be $13.50. What do we have to add each time? Please do so with your calculator. Add it on your calculator. Fill it in. You're going to go back up to the top and fill that in. Yep. Okay. 227. That's going to be probably like right here for him, right? At 4, we're going to go up to $54. Could you plot all of them? Could you gone back to 1 and gone $13.50? Remember hers was 15, so it had to be less, right? And you could plot every single one of these $40.50. That's just barely over the 40. Now take your straight edge and draw the line so that we have a line for Joseph. Okay? So they're showing us Lucy's line. We now are going to put Joseph's line on there. So his started at 0, 0 also. And if we are going to continue this, right, and we're going to put an arrow on it, and we're going to put his name by this one, and you'll do the same thing in your homework when you're doing those 2 lines, okay? You'll put Lacey, and then you'll put Joseph, one like this, okay? And it says, if we were going to write the equation, what would our equation be? What would the equation be for Joseph's? Y equals? What's his pay rate? $13.50 times X. Okay? That would be his equation. It says, well, how do the rates of pay affect what you see on the graph? So, as you are taking a look at this, this is what we want to write down. It affects the steepness, and this is the key thing that we want to get across to you. What does the rate of change, or what does that unit rate affect? It affects the steepness. So please write this down. Some of you aren't writing anything. It affects the steepness of the line. Because Joseph's line is not as steep, his pay rate is actually less than Lacey's, right? Which we knew he was making $15 an hour, she's $13.50. He's making less. Okay. So now we want to finish this last part as we are looking. And this last part, so we have our equations, right? So we understand how to write an equation. You're going to be asked to do that in your homework. This next one says, okay, we have these two cars. Otto has his car with a full tank of gas. It says he then drove 320 miles before stopping to fill up his tank. He filled up 14.7 gallons. Carl's car had a full tank of gas. He drove 265 miles before stopping to fill up his tank. He filled it with 12.9 gallons. How many miles per gallon? So if we are taking a look at that, let's put down Otto's name first. So we got Otto, and we are looking at how many miles did he drive? 320 miles. So you're going to show your work for me so I know how you got the answer. This is all you have to do to show it. Then you're going to put it in your calculator, divide it by 14.7 gallons, right? And you can round this probably to the nearest tenth of a mile. Okay? So do it on your calculator, check with your shoulder partner. So we're looking at miles per gallon. Then we're going to do the same thing for Carl, right? So for Carl, again, check with your shoulder partner. What number should we be dividing for Carl's? Should take our miles, 265 miles, and divide it by 12.9. Remember, when you put this in, you're putting 320 divided by 14.7. So the first person should have came out to be about what? 21.8. 265 divided by 12.9 gallons should be 20.5. And a lot of times they said you could, instead of writing out the word miles per gallon, you could put MPG. It means miles per gallon, right? And so now it says write an equation for each person. We know the unit rate. Write your equation. Try it and check with your shoulder partner. Remember, equations are y equals unit rate times x. Y equals unit rate times x. For what? Otto's equation? Okay. And if I'm looking, Kyle, at Carl's would be who's going faster or who's getting more miles per gallon? Otto, right? Definitely almost 1.3 miles more per gallon if we are looking at that. So your homework. The homework as you are looking at it is going to ask you to find unit rate. Here is the deal. They are telling you pounds per day. Then you have to write an equation. So there is two parts to most of these questions. You first find the unit rate, and then you write an equation. How do we write equations? Y equals unit rate times x. Y equals unit rate times x. Y equals our unit rate times x each time. Okay? So, to find your unit rate, you want to show me what you divided. So as you read number one, you're going to tell us what are our two numbers and how should we put them in with labels for that one. How many pounds were we talking about?
5 pound bag of cat food for every 30 days, what is the unit rate in per pound a day?
So pounds per day. So do we want to put days in the numerator or pounds? Pounds. So please make sure that you are putting this correctly. This is telling us what goes in the numerator divided by, right? So it's 3 pounds per 30 days. And you are trying to find out per 1 day. So you are going to divide, but it's not 10. But I have a lot of people think. They take 30 and divide it by 3. It's 0.1, okay? So when you go, so be really careful when you read the problem. They are going to tell you, when they tell you what is his average rate of speed, if we are looking at this, we're looking at miles per hour, right? So whatever comes before the word per, that's what you have to put in your numerator. The per is like your division by the other unit, okay? Okay? I'm going to hand out a piece of graph paper because when you get to question number 8, they ask you to do this on graph paper. So I'm going to hand out that graph paper. I'm going to have you get started on your homework, and if you have questions, I'll try and